Today we're going to look at quadratics. Our whole next chapter is on graphing and the properties of quadratics. Quadratic has a degree or highest power of 2, a couple examples, and you recognize these are what we've been working with the past week. To graph a quadratic function, things we have to know. First of all, every quadratic is going to look somewhat the same. It's going to look like a parabola. The general shape is going to be a U-shaped graph called a parabola. It will have a vertex, a maximum or a minimum value, a high or a low point, and a graph will have either a high point or a low point, not both. Every parabola or graph of a quadratic will have an axis of symmetry, which means one side will look like the other. It will have a mirror or a twin on the other side, a point that matches up. And we'll be looking at roots and zeros. When it asks you to find the roots or zeros, it's looking for the x-intercepts of the parabola. Where does this graph cross the x-axis? So a couple examples if we're asked to draw the axis of symmetry in. First of all, axis of symmetry is that center line where one side matches up with the other. If I label the vertex, it's this highest point right here. It's a little tough to see on my graph, but it looks like the point -5, 7 would be the label of my vertex. Labeling your axis of symmetry, the axis of symmetry is a line. So this is a vertical line, we label it x equals -5. The zeros, these points right here, one of them happens at -7, the other one happens at -3. There's one, there's 0. Drawing the axis of symmetry on the next one. This line here, x equals 1. The vertex is this bottom point right here. It's a low point, 1, -9. -8 looks like, -8. Zeros for this one. Crosses here and here. Looks like -5 and 7 for your zeros. And lastly, I've got an axis of symmetry here. Vertex is here. Axis of symmetry would be labeled x equals -1. Vertex would be labeled -1, 2. That's what this point is. And zeros, well, where does it cross the x-axis? Where is it equal 0? It's not. It doesn't ever cross the x-axis, so we put none. There are no zeros. Domain describes the x values of a function, and range describes the y values. Your x values are here, your y values are here. Domain and range, x and y values of a function. So if I look at this parabola, the x values that I'm allowed to plug in, well, this graph keeps going forever, and it's going to spread out. And it's going to eventually go down towards -infinity. This graph is going to keep spreading out this way and keep going down forever. Domain on all parabolas is actually all the same. It's all real numbers. You can plug anything in. The range, though, on this parabola is limited. We can't get any y value out. The highest y value we get is right here, that vertex, that maximum value. And the highest y value we get is 7, right there. So my y value, my range, is all y values in this case that are less than or equal to 7, because my graph is opening down. Next one. Again, my domain, the x's are covered pretty much all the way through. This is going to keep going up and spreading out. X is all real numbers. The domain is all real numbers. And then your range, what kind of y values do you get out? Well, look at your vertex. This is the low point in this case. So I get values that are -8 and bigger. So all my y values, my outputs are going to be greater than or equal to -8. And the last one. Domain, still all real numbers. The range, in this case, y values that are greater than or equal to 2. To graph the most simple quadratic equation, y equals x squared, this is called the parent. We've talked about this before, the parent function. Make a table. To graph anything, make a table. So when I plug in a -2 squared would be 4. I can graph that point. -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. So we see that symmetry. We see where one side matches another or mirrors the other. This is the most basic quadratic function right there. Label the vertex. 0 is an axis of symmetry. My vertex is this point here, 0, 0. My zeros, there's 1, 0. It actually happens at 0, right there. And then the axis of symmetry is the line right here, which is the line x equals 0. So all sorts of zeros there. Graphing another that maybe looks just a little more complicated. Basically just make a table. To graph anything, make a table. So I've given you values to plug in a 0. 0 squared minus 4 times 0. 0. If you plug in a 1, 1 squared minus 4 times 1. Plug in a 2, a 3, a 4. And we get those values. Again, we see the table having that symmetry matching up. If we were to graph these points, we'd get that. This parabola here. Vertex is this point down here. 2, -4. Axis of symmetry. X equals 2. And then if I were to identify the zeros, actually, let's label them. Let's label them on our graph. This point here, 4, 0. This point here, 0, 0. Just put them right on our graph too. So go back and re-watch anything you didn't catch and come up and grab the worksheet, and you can finish that up for your homework.